Good night. Hello, hello. So tonight we are going to continue the game that we started creating our last session, which is a simple spaceship shooter, 2D on the console using FatScript. My name is Antonio. I'm the author of the FatScript programming language, and the FatScript sessions happen every Monday at 20 uh, hours Brazilian time. And I'm here today to take any questions. If anyone wants to ask anything, I'll be very happy to also explain a little bit. Just put your questions on the chat. And if you would like to, if you're watching this video after it's been recorded, you can also just put a like, put some comments, and I'll be happy to respond it either on the comments or maybe even on the next session. Okay, so let's see where we had stopped. So I had created this file here the last time, which is basically the structure of our game. So we have created like a type. In FatScript, we call it type. It's like a class for position. And we did it also for a game object, which we had a few different. I had a few different ideas at some point, but then I decided to just unify all the kinds of objects that we are going to work with in this little game, just calling it game object because they are all on the screen. They're just like the sprite is just like one character we're using to represent bullets or spaceships or whatever. And then there's like the basic then there is like methods of this class, which I might even just put some more here, but the ones most important are draw and erase. So when we create our frames, what happens is that we won't erase the whole screen in the console, because that creates a lot of flickering. So to improve performance and avoid the flickering as much as we can, what we do is we just erase that single object when it moves and we draw it again. So that way we will be doing a lot less re-rendering on the console. That's one little trick we are using here. And then all else is just the standard libraries of FatScript. Okay, and at the last time, what we had done was a little bit of collision as well. So I'm putting the different kinds of elements we have here in the screen, like particles and enemies, in separate collections, lists, which I'm marking here with the tilde, which indicates they are mutable. And then I iterate over the things that I have within particles and I update them. I iterate over enemies and I test collision between particles and enemies somewhere here. Collide with particle, yeah, which does some little maths, like I check for a range, not just for position, because as the like the bullet or whatever we call it here, I think it's bullets that we are calling these I think we are just calling it particle. Yeah, bullet color. Okay, so I'm saying that the ship shoots bullets. It could be rockets. It could be anything else, lasers, whatever. So these bullets, they travel actually possibly faster than just one character, like one column at a time when they're traveling. So we have to check for a range. Because we don't do it, maybe like the amount of travel that we get, it depends on the frame rate. So even the way I'm actually doing it is not 100% guaranteed that it will work, but it's currently working always. So I'm adding 2 and getting like +2 and -2 on that range. So it's pretty much like 5 positions. We are kind of like 5 columns on the screen. We are testing if the bullets and the space and the enemy, they are within that range of 5 columns, so they're close enough and they are on the same line. Then we have in the same row we have a collision. So that's basically how we're testing it. And I'm going to show how the game is currently working. I'm just going to call fry main, and that gives us the game. So basically I can move up and down. There's no generation of enemies at this moment. I can press spacebar and it shoots these particles. And if I press the E letter, it creates this enemy and I can shoot the enemy. Yeah, I can still move, I can shoot, and eventually I get to hit the enemy. Okay, so that's basically currently all that is happening here. So I think that the next steps are to get this game more like a game. We need to have some indication for like the points, like the score, how many ships or points did we make during this game. We might want to do some automatic creation of enemies, of course. We might have upgrades, maybe. We could have like some kind of shooting that goes in all directions. We could have also some explosion for the spaceships that are hit. That actually is one very interesting thing we could do. And I'm planning to start with giving some more impression to the game that we are moving. So for that to happen, I think that one thing we can add is like stars in the background. And these stars, they are just randomly placed in the scenario, and they will just like be moving. And everything will be drawn on top of them. So there is like very, very little chance that they would actually be drawn over, let's say, for example, another object. So we draw these stars randomly on the screen, and we then just move them. We can just move them back to some other place when they reach the end of the screen. We just move them back to the beginning, and so we have just these stars passing very slowly on the background, and they will give us some impression that we are moving somewhere. So I will start with our stars. Okay. So so let's create another thing here which we need to initialize, which is even before our player, which is the stars. Okay, so we're gonna init stars, and our stars are also going to be okay. We're also going to make them a list. We're gonna call it stars, and instead of starting with an empty list, I'm actually going to add a number of stars. So for now, I'm just going to call it n stars. And the number of stars is going to be, I don't know, 20 is also fine. It could be more, it could be less. I think that won't impact that much the performance of the game, so I'm just going to use that. Okay, so where were we? Stars. Okay, so we need to create those stars. So instead of using a list, I'm just going to map over a range. So this range is going to be n stars, and we use the at operator for that. This maps over a range, so you need a function that takes in the argument, which is the n, or the index, or like the it will go from 0, 1, 2, 3. We actually don't even need to take that argument, because we're not too worried with the n right now. We won't be using that argument. We just need to create a star. So even, I don't think I didn't need brackets here. We're just going to call it game object. Okay, we know they are the stars. So for the position, one interesting thing here is we need to put it within a certain range. Now, how do I get this range in FatScript? In this case, let's get here to just get some help here from the maths library. So if I do here help math, we do have a random function. Okay, so random just returns a random where it goes from 0 to something less than 1. So I'm going to define a function before anything, like a method that gives me, that ensures me that I can get a number which is within a certain range, which I know. So I want a number between, like, I don't know, 1 and 10. So it will always give me a number between that range. So I'm gonna first, before we go and create this this game object, which it will need a position here. It will also need a sprite, which for the stars, I think it's fine for the stars to be just a dot. And for the color, color pair, we can just say that these are like blue, I don't know, color blue, which would be star pair. So now we do have a color pair, which is star pair. But for the position, we need the position to be a range within, it needs to be generated randomly within a certain space. So before we go there, we will just create a function to give us what we exactly need, which is a random between. Okay, so there's no function provided by the library itself that would return this, but basically it will be math.random, and then I need to multiply this by the maximum amount, which I want. Like, for example, if I wanted to have like a number, like a dice, I would have to multiply it by 6, right? So I'm gonna take actually 2 arguments here, which is the minimum value and then the maximum value. Let's just say there are numbers, right? Okay. And this returns a number. We are not required to declare types in FatScript, but it always helps to add this information, this type information, because it makes any errors will be much more easier to catch if we have them. Okay, so basically now that we have this, let me increase the screen. So now that we have this, if we do run this, it will give us numbers from 0 to up to 5 point something. So we can do one thing here, which is truncate, and this will remove whatever are the decimals that we have here. So it will just get us like the actual integer value, which would go from 0 to 5. Now we know it goes from 0 to 5, so we want to specify a minimum value, which would be well, whatever we put here, if we say 1 to 6, so it would be minimum plus the actual maximum, right? If we say 0, it would be 0 plus 6. Will that work? 0, no, we would just get from 1 to 6, 1 to 5. So we want to include the last number. We actually need to do a plus 1 at the very end of this thing. Exactly what we needed, which was a number between the minimum and maximum. Now, for the position, we know we want to create these stars between like the positions of the screen. So we define it like the x, the last position, we have like a limit which is on the top is 1 and at the bottom is 22. So we don't want to we don't want to draw at 0. We don't want to draw at 23. So we want to start from here. We need a position which is an x and y. So x equals something and y equals something. Okay, so this is the column. So we need a number which goes from 1 until the maximum. So what is this? This is like the maximum. Okay, so we do have a max x and y, but we don't have a minimum x. I think I didn't put it anywhere, but we know it's a 1. Okay, so we want to put it random between 1 and max dot, I think it's x here, right? Yeah, 79 x, but minus 1, because we want it between 1 and x minus 1. We don't want it to get to 79 actually, because that's already the hard last line. And here also on our, now this one is actually easier. The random between for the y is just like this limit. So we do have this limit. You could also create a limit for the x. I think it's going to be easier. So we do have a limit at the start, or limit right, and a limit left. Okay, actually left and right, I think it's more sensible. So it starts at left 1 and it ends with 78. So now we don't have to do that math there, and it's actually easier to follow what we're doing. So limit x dot left, limit x dot right. And here we have limit y dot top, limit y dot bottom. Okay, does that make sense? So now we are creating a lot of stars with a position that ranges here, and it does do that star pair. And we do need to do one more thing here, which is stars dot walk, and we need to draw them. Draw. So let's see if that took any effect on what we were trying to accomplish here. And okay, cool. We have some stars, but they don't move. And if I move over them, they're just gone because they're not going to be redrawn. So that's actually fine, somewhat fine, because if any other object comes over the stars are just not going to be rendered on that frame. Now, I think we can add a movement here for the stars. The way we did it for the other ones, I don't quite remember, but they should be here. So, for example, for when we shoot, we add a vector here, 40. We definitely don't need all that energy here for the stars. They move very slowly. Um, so I think we just call it movement, really. Movement equals vector, and I'm just going to put a very small number here. Maybe even 3 would be all right. Okay, so now for this to actually work, we need to do the same that we do with the bullets. Particles, particle draw, apply movement to bullet, and we call it bullet slash particles. Now, I'm just gonna call it bullets to make it simpler, okay? And I'm gonna add also here the same logic now for the stars. So this is stars equals stars, where a star is erased and updated then if the star position exceeds the max x, then one thing we can do here is we can just update the star position, right? So let's think. First, it's not going to be the max. It's going to be if the position of the star is actually less. Also, was it less than the max? It will draw. But if it's not, we need to move it. I think we are just gonna draw it anyway, and we are gonna return the particle always. However, we might need to set the position to a new position, and positions are allowed to be altered. If I remember correctly, you can just alter them. Yes, you can just assign a new position for your star. So if the star is less than limit y, limit x, we have it here at the left. So if it gets lower than our left limit after updating it, no, we don't need to do anything here. We will just continue updating anyway. But here we need to do one thing. We need to say, okay, star position equals position, and the new position is basically the previous position of x and the previous position of y. But there is something that changes here, the x position. So the x position needs to go to the very end. We could actually randomize the y if we wanted, just for it to draw in a completely different y position. That would be actually interesting. So let's see here, the function that we are already using here is between the top and the bottom. So we're going to draw it here. We're going to change and say the y is this thing. But the x is going to be exactly at the limit. Okay, so we're going to just place it at the limit x dot right. So each of them, when they reach the left, they move to the right. And I think that's it. It just keeps on going here. To be honest, we don't even need to do this assignment that we are doing here. We could just say stars dot walk and then take this whole logic here and remove this part here and this part. We're not even updating. We don't really need to update the other part. So we just do this. We draw, and we don't store the result of this operation. We just, this is like a walk, is like a for each. So we just go over and mutate the state of each star. We erase it, draw it again, and now we should have stars that are moving. So let's try this again. Can resolve scope of draw, because it's not particle, it's star. Okay, that makes sense. They're still moving in the wrong direction. And one thing I noticed is it didn't get that interesting, is that they are moving so slow. So let's put it random between -2 and actually -5 and -2. So they're all gonna have different speeds at this point, I guess. Maybe this is too slow. Yeah, it's definitely too slow, isn't it? Okay, some of them could be a bit faster. So I'm just going to increase this a little bit. I'm just going to put 15, and here I'm going to put 5, which is like the lowest. And maybe you could have a little bit more of stars. I'm not sure if this is going to take a toll. I don't think so. Maybe the brightness is also not great. The fact that some of them are a little bit too dark. But let's see. When one of these guys is like at the very end, it just moves to the other side of the screen, like, but not really at the same place. And even if you shoot it, it goes away, but then it comes back, because this is, they're look like just transparent to my bullets. Okay, so I think we do have the effect that I wanted. It's not moving as smoothly as I wanted, maybe because also it kind of kills my ship if it goes over it. You see. So I think I might have to increase a little bit the minimum value so that they don't that they move a little bit faster altogether. So I'm moving this to 10 and this here to 20. So they're almost shooting through now. They're gonna be moving very fast. But okay, I think overall this gives us some feeling that these stars are moving. I don't know why some of them are just like they look like they're not moving at all. I don't quite get it. There must be a problem with some of the stars. So random between -20, -10. Let's just break here and see what we get from the stars break. I want to see the value of my stars. So let's look at the stars. So we got, for movement, we got -8, -5, -5. That's just, wait. Map. Movement dot x, which is the only value that we are interested in. And we actually get a few ones that are getting us a 0, and they're not really moving in the amount that I wanted. So something is a little bit off with this like -20, -10 thing. It's not working as I expected with the random between. Now, why would that last? right. I got, this was on me. I didn't do the right maths here. So now the function is correct. Now this thing here is too fast. So I probably could just have stayed with what I originally did, which was like minus 15 and minus 10, or even minus 8. I don't know, something like that. Probably that's good enough in terms of speed. I think it already feels a little bit more like we're moving through like a star system here. I know we could have worked out the colors to have like brighter colors and darker colors for a true color system. I'm not gonna do this right now. We can improve on that later on. For now, I think this is just great. It looks like you got destroyed here. So one thing I could actually check is when I'm about to draw the star when it moves, is if it's on the same position of the player. So if star position is not the same as player position, in that's the only case where we draw. If it's not, then we don't draw. Then we just erase it. And now if we try to play position can't resolve scope of position F 12012 star, not start, star. Okay, yeah, that makes sense. Okay, now it still does erase us. So there's still some problem with that. Star.erase. Okay, we are always erasing it. So the problem with erase is we cannot also erase it if, so I need to check it twice. That's kind of a little bit sucky, because I could extract that as a boolean. Is player overlay equals this thing, and then I don't need to test it. I'm gonna just test the actual boolean value of that. This player overlay, and then erase. We always update regardless, and if it's player overlay, this would it is not player overlay. Okay, so now it describes what it actually is. So these are gonna hit him. Oh, it still draws over it. It's not working. It kind of almost is working, but not 100%. So if it's not player overlays or erase, so it compares the position here. Oh, I see the problem. We actually need to check it both times, because it does update, and it in one case or in the other we need to check it. So okay, let's do the double check. It's probably not a big deal of overhead anyway, so I check it twice. It's still drawing over the player. That's annoying. Star position different from the player position, then you erase it. Now I think this is because X truncates. I think we will need to do this. We will need to get the actual position, like the actual position, not like an approximation here, for this to work. So we need to truncate the X, we need to truncate the Y. and then we know for sure, for a fact, that they are one on top of the other. Or we do something like with what we did here, with the collide. I think for the case in at hand here, we can just do the x truncates, y truncate, and all of that. Okay, so we will have to do this. Because we will have to do this more than once, I will just create a function. So collide with star, and this is also a method, and it takes the player. I mean, it just needs the star already. The players takes implicitly. We could just say object, which could be any game object, and the star, which is also a game object. Which we know the stars, they move slowly, and the only reason why we were trying to collide them is to see if there's an exact match of position, right? So if position dot truncate, we are talking about star. Equals that also dot truncate, and then we get the other part of it, which is x. So if x and y they match, then yes, this is a collision, true. Otherwise, no, it's not. Okay, I think that's perfectly sensible. So if collide with star, player, comma star, if not collide with star, then star raise. If not collide with star again, then star draw. Okay, well, that's a lot more effort, but I think this should now work. Now they transparently pass through the player, and they never draw over the player. So they just happen to go away, and they come back again when they over the player. When they pass the player, they just rebirth. They will be recreated. And when they get to the end of our field, they are just created at a different y position of the other side. So now we have a nice star field going on. We still can create our enemies, and we can shoot at the enemies, but I'm using the E key to create our enemies. I need more bullets to destroy all these enemies. Okay, what we do need now is to create the enemies at random as well. Okay, so one thing that we can do here is, for now, I'm just gonna create like another global state here, which is level. Okay, we might move this actually to a state, like a game. Let's make it already like a game state. I think that's a better decision. So I'm going to create an object here, game. I'm just going to call it state. Okay, so state basically has one of the things, which is a level, and then the level is actually mutable, and we're going to just start at level 1, which is a sensible default, and then we can increase this, and this will be like a multiplier of the chance that we we have to create new enemies. I'm gonna just leave this E for creating enemy for now here, so we can actually play a little bit with this. But what will happen is, like, every time we enter this this main loop, we will have a chance to create an enemy. So I'm gonna do it before I draw the enemies, before I move them, erase, move, particles, erase, all that logic. I'm just gonna do this before. And I'm gonna place the enemy at the limit at the right. So for chance, FatScript does have one interesting thing. If you wanna use chance of something happening, there's like a fuzzy class. So it's almost like a maybe boolean. So let me get some help on that so you can see. Help fuzzy. Okay, so you can just use this class, which it has something called decide. So the number it takes is a chance. Okay, so it's an argument. So it goes from 1 being the highest probability and 0 being the least probability. So if we consider that every frame we have a chance of something like that happening, we could start probably with a 5% chance or something like that. So I'm just gonna multiply the level by 5%. So this chance is like the difficulty step, if you like. And if it's a 5% chance, I'm just gonna put here. Maybe we should even multiply this by frames per second so the game doesn't lose its reference if we kind of change the frames per second later on. So for now, what I'm going to do is I'm just going to say this is a percent chance of new enemy every second. Okay. Now, what you can do here is you can create a fuzzy. For now, I'm just not going to handle the level up part of the thing. So I'm just going to say init level. We need to come back to this init level, and we will say that chance to create chance new enemy equals fuzzy. And then we have that chance, how the difficulty step times the state level. Where is it? Okay. Difficulty step times our state dot level. And then guess what? Every frame but that's every second, not every frame. So let's increase this. We have like a 0.5. Like every second we have like a chance of getting a new enemy 50%. That's more reasonable. For seconds, I think. Or maybe you can start with a little bit less, like 0.3. So every 3 seconds, that's a lot, isn't it? Yeah, I'm gonna I think like half. So roughly every 2 seconds you get a new enemy for the first level. I think that's all right. We will be increasing that at each level. It could double. So we could have a different mathematical function for the increasing of the difficulty, but for me, I think that just multiplying it by 2 is actually fine. It will feel very steep curve of difficulty increase. So chance new enemy difficulty step state level, and we need to divide this whole thing by frames per second. Now the chance new enemy is just something which is already there to be this used, so we just say decide, and if there is a chance to have a new enemy, so if decide this, it decides to true, so we need to add this new enemy. So we just say enemies plus equals our new enemy, which is basically what we were doing here when we were pressing E. Now we could even remove that other part there. I don't know if we need that, but what I want to test right now is that this works. So I'm just gonna play again, and now enemies are just coming out of the blue. They just. But there is one problem. They're actually coming at the same position that I am. Wow, that's a lot of enemies there. Okay, and they currently they don't shoot me, so that's nice. But eventually, I should also make them shoot me. Right, it's already starting to look like a game. So because they are shooting, because they're not shooting, for now we will just have the enemies coming into my direction, and they're not so much of a threat, but they will get much worse once they start shooting. But the main problem here is the position of the Y. The Y position here should be kind of same like what we have with the stars, right? It should just be within a range from the top to the bottom. So this here, random limits Y and the bottom. So where is my new enemy? Here. Okay, so that's basically, we created at the position at the very end, but then at a random between limit of the top, limit of the bottom, right? So now it should just create it at the position that we want. Okay, let's try again. Now we get the enemies just coming up at any random position. The funny fact is that sometimes I'm getting much more than one enemy. I still don't have like a point system where I can know how much I have scored, but I think the game is now starting to appear more like a game, right? You have that feeling of, well, we're moving here, and then you just get the chance that eventually you just get some enemies sometimes. Yeah, I think that we're getting there with this. So for today, I think we spent here already almost 1 hour. I think I lost a little bit of time there with that particular part where I was trying to figure out what was going wrong with the random between part. But that's part of programming is making these kind of mistakes and having to look again and again and iterate over to figure out what was happening. I hope this was also an interesting experience of like debugging using our iterative debugger from using Fry. So it's a way for you to test things that are actually happening in your code without having to put a lot of tracing code for tracing. You can just use this strategy that I use. You just strategically place a break statement where you need it, and then you just put a minus dash I or minus iterative in your CLI command. When you call Fry, there's like this option, iterative, and it will enable the REPL during the file execution. So that's what you need to be able to actually jump into a break. And then you can just examine anything. So for example, you're here in the middle of your loop, before you start actually doing anything with the keys, you can just jump in here and see what's the state of the game at this point, and you can just read and change and do whatever you like. Like I want to know where's my player, and it just tells you where's your player, what's the stars. Okay, this is stars, a lot of game objects there. Do you have any enemies? Probably not. Maybe I have one. I don't have any. Okay, so it's an empty list. What do I have at state? I have added there a level. Okay, all this stuff is just basically, you know, it's just happening at this point. You press Ctrl D and it will execute and stop there again. But if you want to just continue, you can just, if you want this breakpoint to be forgotten for this session, you can just say unset. And then you continue and it will not ask that thing again. Now, you can just keep on going and put other breakpoints in other places. But for this time, it won't be stopping there anymore. It will just execute the rest of the code. Right? One more thing which I'm definitely missing here is we need to have a way to exit the game. So I'm just gonna add here a few more conditions. Up, down, space, we should. And I think here we should definitely have Q or ESC key. Either we just need to exit. So what I'm going to do to exit, I could actually change this to a certain condition like game running or something like that. But for simplicity, right now, the most simple thing I can do is just ask system to exit. Okay, so I'm just gonna say system.exit, and here success code. It just exits the game. Now I can just press Q and it exits the game, right? So, or ESC, it just exits the game. So now we have a way to end the game. Cool. So I think that we covered a lot in our session for today. I think we will still have one more at least part of this thing. We still need the high scores. We still need the enemies to shoot. We might even get to getting some upgrades in the game, or maybe having some more advanced enemies as you play and you evolve, and the level you level up. We can think of things. I hope this was already like some interest, and I'm just making it slowly grow into a more complex game as we go. So that's basically it for today. See you on the next video. If you are watching this video and you liked it, please press a like button so that YouTube knows this is a relevant content. Subscribe to the channel so you get notified the next time we go live. So yeah, that's it for today. Bye bye. See you the next Monday.